Radio engineering, graphics and design learners, welcome to this very important video detailing SANS symbols and conventions that you need to know when it comes to mechanical drawings. Now this is very applicable for all of you writing grade 10 to 12 paper 2 in engineering, graphics and design. So please make sure you pay attention as I talk you through the different conventions and representations of views, dimensions, and of course the big one a bit later on, welding symbols. That's very important, and machining symbols for you. Now we're going to start off here with different interrupted views when we have a cutting plane. All right, present. So the first one that we look at here is a half section. Now on the left hand side is the correct representation, on the right hand side the incorrect. Now please take note here that when the hatching lines come all the way to the center line, then we have a solid line that needs to be drawn. That's a correct representation. If those hatching lines meet your center line there of that half section and this line remains the center line, it's going to be incorrect. When the hatching in this example do not meet the center line, then that center line remains a standard center line. So that's very important. These are the two correct ways. A partial section is shown here. Remember, this is always drawn freehand, and that's when you, on something like a stud or a shaft or a fixture, and you're going to want to show more detail, you're just going to do a partial section and hatch that. When we looked at the revolved section, it's indicated here in this. It's when we cut through a section of a part and we just revolve or turn that section to show in position what is the section like, how does that component look, or how is it shaped. That is our revolved section. A removed section is indicated here in this document, and you can see if I would cut through here, that's the shape of it, cut through there, etc. Those are removed sections, and here are some other examples. Now here's a tip for you. This document is as a download in the description, so please make sure you don't download it and have a look, study this for yourselves as I talk you through it. Also remember, this information is not only just valuable for you, your friends are going to benefit and like you a lot because you share this with them. All right, this one is a common one that I've actually seen in grade 12 papers recently, so please grade 12 pay attention to this. When you have 3 consecutive sections, it's called successive sections, like you see here, and each one of them are then labeled in the preferred arrangement, section A, section B, section C. You might still sometimes have the layout like this, but again, they are successive sections. Take a look at some previous papers actually have this question, so you can expect something like that coming your way. Then it's important for you to remember on exceptions, what are the parts of when we do a section like a full sectional front view, for instance, what are the components that's not hatched? All right, and here it's listed for you. Ribs, like you see here, shafts, bolts, nuts, rivets, rods, keys, pins, any similar component that's used to fix or keep something together. Your key way, those things are not sectioned. All right, a rib is only sectioned when it's cut in its shortest end. So like here longitudinally, it's not sectioned. Please take note of that. If we look at the different cutting planes that you can expect to find in this paper, we of course know all the standard one, but this is a multi-plane section. We actually have 2 planes with a step in. Now take note here, you're never going to draw that corner of that step there. No, it's going to just look as it is here in the example. No edge line here is shown when we're cutting on a multiple plane. All right, here's another example just showing you that exact same layout. You can see here the multiple plane, but we look at it in the line of sight without all of those corners that you would have seen there. Okay, that's a multi-plane section. Let's look at the next one, which is an aligned section. And I think you're really enjoying this video because, of course, there is a lot of information here that some of you might only see for the first time today. So please keep up with me. These are things that's going to be asked in the mechanical analytical. All right, let's say we've got a spoke here and the cutting plane is aligned like this. When we then draw, for instance, the right view, if you look at the direction of the arrow, we're looking at the right. Here it is drawn. We rotate this part to a vertical position. And you can see that we draw the aligned section just as it would, but the fact of the matter is we're following that section line there. That's called an aligned section. You've got a variation on this where if we just do a true view of this, for instance, and we just follow our cutting plane with a step there, we would only draw half of it, true front projection of that part, and then this part is drawn as a true front projection. But there's also opportunity for us, again, using the line method, to have that cutting plane at an angle here and then flipping that as shown here to show a full section that's aligned for us. So just keep track of the different ways of presenting a aligned section. And then here is an aligned section for convenience, where they've actually given you the cutting plane. You can see here it doesn't go through the spoke, but when we draw it, we actually show it as a aligned section that was rotated. So just take note of that. These are all examples of aligned sections, and this one specifically is the one for convenience, showing the spoke there. All right, next one is squares and other flat surfaces that we can view here. This is a common question. I haven't seen many papers without a question like this. When there's a cross on a surface, it means that that surface is flat, or that there is actually a square on a shaft, on a cylinder. And there you can see the side view without those flat surfaces indicated. All right. Then these are most of the time also in your actual workbooks or textbooks. Just take note of, you've got the detailed representation of different components, and the conventional one is the one that you must be able to draw in freehand come your final exam. So here we have a dowel, and this is of course the end view here. External screw threads, you can see the detailed representation and the conventional representation. All right, on that, make sure you can draw that. You've got internal screw threads and its conventional representation. Then we've got screw threads assembly, all right, where we've actually now taken a crab screw, for instance, and it's been screwed into an internal screw thread. All right, so just make sure that's when something is joined together. You see the internal screw thread that's screwed, or the stud or the external screw thread screwed into the internal screw thread. Then a thread insert. Now this isn't but very common, but just take note of this one. And this one is important, the spline shaft. You're never going to draw it in all detail. You will use this convention to draw that. The same here with the serrated shaft, just the part here. And I think they're going to show a gear on the next one that's going to also help you in that. Here is your cylindrical features, and this is also a common answer question. We have a cylindrical helical spring, and the simplified way that we're going to draw it. This is a cylindrical one with which is a square wire. So just take note of that added on. I'm wondering if that's not something that they might ask. When it's got that square, it just means to us that the wire that is made using that spring wire is squared. All right, then a conical helical, so it's got a smaller diameter on the one side and a larger one on the other side. Then we've got one with a tension spring and a circular end here. We've got a barrel-shaped helical. All right, these are less common, but I think these top two very important for you guys. Then this has also been asked previously, straight knurling. How it's shown conventionally, please remember to draw that. That's a diamond knurling, also again important for you. Then holes on a pitch. If we've got a pitch circle diameter, is actually the abbreviation here, PCD, or pitch circle diameter. We only draw one and the others are just indicated. So this method important for you. Holes on a linear pitch, again, not necessary to draw all of them, just indicate the centers of those holes. And then a bearing, again, the detailed representation. This was also, I think, last year, so please make note that you know that one. All right, we're pushing through here to interrupted views. This is also a common question. How do I indicate interrupted views? Please let me zoom in here, because I think it's going to be better for you to see it this way. So I'll just zoom out a little bit. I want to make sure I've got 3 columns there. Okay, if we look at this, if you've got a solid shaft, it's just an S-break like that. But the moment you're working with a pipe, for instance, remember there needs to be a double line there on the inside as visible. And then if it's a square, you can just do a break line like that. All right. Then an interrupted view on a round section. There's another example of that. And remember the hatching there. Okay. Here we've got repeated features. So let's say that's repeating. When we draw it conventionally, we not necessarily have to draw all three in place, but just one and repeat it. The same here with the symmetrical components. So we can do the symmetry of that with two lines there on either side. And if you just draw a quarter, you're going to just have to add the center lines with, again, symmetry symbols on either side. Okay, take note of that one. Then here's the gears that I referred to earlier. So bevel gear with its representation, conventional representation, never going to draw all of those gears in there. An assembly, bevel gear assembly. I'm doubting that this will be asked in a way of just, go and draw a bevel gear, but they might want you to identify it. And so remember, this is a bevel gear assembly where I actually have a smaller gear and a larger gear, and they are actually, joining each other in their gears. Then you've got a spur gear here, and you've got a spur gear assembly, again, two or more gears at a time. All right, and just take note on how that detail looks. All right, we're almost finished off with this part before we get to the machining. Just that I'm mentioning here, that's important. So CSK stands for countersunk. That's something that's been asked in the past. Just take note again how these measurements are, especially the diameter signs. A lot of times the kids forget the diameters. The counter bore, it's the abbreviation there is C bore. Now something that's been asked here in the past is diameter 9. And what is this plus 0.05 and the 0 mean? Well, it means that size in the end can be 9.05. So there can be a bit of play with regards to the maximum, but the minimum is the diameter 9. It cannot be smaller than the 9, where in this instance here it says 3.5 and the 0 is the maximum, so the maximum is 35, but smaller could have been 3.5 minus 0.2, which will take me to 34.8, for instance. So just take note of that. And then S face is the abbreviation for spot face. Okay, right, here we go for welding symbols. I think a lot of you waited for this one, and let me just I think I'll position it that way, and then you can have a look at that. All right, so if we look at this is a standard welding symbol, and you need to be able to identify what are the different components on this. So the first one, this circle here, that's the site or the field of the weld. Okay, the exact placement, the site of that weld. The number 2 here indicates an all-round welding, especially when welding a stud, means all-around weld. Then this number here references the length of the weld, so in that sense 25 millimeters. And this one is the pitch of the weld, the distance between consecutive welds. So you might have a 25 millimeter part, and then a 100 millimeter gap, and then another 25 100 millimeter gaps. So that's the pitch. At number 10 here, that is the width of the weld indicated for us here. And just we'll talk about that in the next screen maybe. Here it is, all right, let's go on to this one, and there we go. All right, so at number 6 here, we're talking about the welding symbol on arrow side and welding symbol on other side. Those are the two indicators there. Number 8 here is the welding symbol or contour, and this can, be different, can look differently, but the placement of it is the welding symbol or the contour is going to be indicated here. And then at number 9 here is our specifications and the process. So it's arc welding, and it is so that's the arrow side, and that's the other side that they refer to here in number 6 and 7. All right, so please take a moment to just understand which goes where, because they will most likely just ask you to identify it, or they might ask you, what does this 25 mean? And you will have to remember that that is the length of the weld. And the 100, what does that refer to? Well, that's the pitch of the weld. Okay, so those kind of things you might be able to identify. And this document is as a download in the description. All right, machining symbols, that's another important part that they might ask you. This is a machining symbol, and again, the areas here refers to different specifications of that machining. So A here will be the roughness value of the machining. In other words, if I would take my finger over the surface that's been machined, how rough is it? You know, the lower that is, the smoother that surface is going to be. B is the production method that's used, grinding or sanding or whatever that is. C is the sample length. D is your direction of lay, and we're going to look at some examples of that, perpendicular or parallel, etc. And then E is the machining allowance, again, the accuracy almost of that. All right, so let's look at some of the techniques here. I'll zoom out for you a little bit. Sorry for that. Just zoom out a little bit. All right, so there's a machining symbol, and we've said that D is the direction of the lay, so the direction of the machining. Parallel, you would just sand in a parallel direction. A perpendicular sign would be to that surface, a perpendicular angle to the surface. If we look here, multi-directional, it's almost similar to an orbital sander. You know, it's a multi-directional pattern. We've got a crossed pattern, and then we've got a circular pattern here and a radial pattern. So just be able to identify those different patterns. Right, that's the end of the SUNS document. Of course, this document, the first part is the civil, and the second part that I've discussed now is your mechanical. So please make sure you take note of these different symbols, you share it with your friends, and you prepare so that you're able to understand and interpret these different symbols and conventions. Thank you so much for watching. Now it's your turn.